What if I told you that some of the biggest scientific discoveries were actually mistakes? That's right, folks. From ancient fossils to cutting-edge space exploration, even the brightest minds can get it wrong sometimes. And when they do, the consequences can be mind-blowing. Prepare to be shocked, excited, and maybe even a little scared as we dive into the top 10 science mistakes that changed the world forever. We're talking about blunders so big, they'll make you question everything you thought you knew about science. So, buckle up, get ready for a wild ride through the history of scientific mishaps, and remember, sometimes the greatest discoveries come from the most unexpected places, even our mistakes. Let's get started. Okay, picture this, 1912 England. Amateur archaeologist Charles Dawson discovers skull fragments and a jawbone in a gravel pit. They seem to belong to an early human ancestor, a missing link between apes and humans. The find, dubbed Piltdown Man, sends shockwaves through the scientific community. But here's the thing. Piltdown Man was a hoax. Decades later, scientists proved that the skull belonged to a modern human and the jawbone to an orangutan. Someone had deliberately planted and altered these bones, staining them to appear ancient. The motive? Fame, perhaps, or a desire to mislead the scientific establishment. Whatever the reason, the Piltdown Man hoax serves as a stark reminder: always question, always verify. In 1989, chemists Martin Fleischmann and Stanley Pons called a press conference that sent the world into a frenzy. They claimed to have achieved nuclear fusion at room temperature, a feat previously thought impossible. This cold fusion, as it was called, promised a clean, limitless source of energy, capturing the imaginations of scientists and the public alike. But then came the crash. Other scientists couldn't replicate the results. Flaws were found in the original experiment, and the initial excitement fizzled out, leaving behind a trail of disappointment and skepticism. Cold fusion became synonymous with scientific overreach, a cautionary tale of unchecked optimism. The story of cold fusion is a reminder that science is a process of trial and error, of bold claims and rigorous testing. It's about pushing the boundaries of knowledge, but also about acknowledging when our reach exceeds our grasp. Space exploration is hard, folks. It requires meticulous planning, cutting-edge technology, and billions of dollars. But sometimes, all it takes to derail a mission is a simple mix-up of units. In 1999, NASA's Mars Climate Orbiter, a $125 million probe, was supposed to enter Martian orbit and study the planet's atmosphere. Instead, it went silent, lost forever in the vastness of space. The reason? One team used the metric system, while another used Imperial units. The loss of the Mars Climate Orbiter was a major setback for NASA, a stark reminder that even the smallest details matter in space exploration. It highlighted the importance of clear communication, standardized procedures, and meticulous attention to detail. This incident underscores a fundamental truth. In science, precision is paramount. January 28, 1986, a day etched in the memory of a generation. The Space Shuttle Challenger, carrying 7 astronauts, lifted off from Kennedy Space Center, watched by millions around the world. Just 73 seconds later, tragedy struck. The shuttle disintegrated in a fiery explosion, claiming the lives of all on board. The investigation revealed that the disaster was preventable, caused by the failure of O-rings, rubber seals, in the solid rocket boosters. These O-rings were known to be vulnerable to cold temperatures, and on that fateful morning, the launch pad temperature was unusually low. The Challenger disaster had a profound impact on NASA, leading to a complete overhaul of safety procedures and a renewed focus on engineering rigor. It underscores the importance of ethical decision-making, of prioritizing safety over expediency, and of always remembering the human lives at stake in any scientific endeavor. The Hubble Space Telescope, launched in 1990, was supposed to revolutionize astronomy, offering us unprecedented views of the cosmos. But soon after its deployment, a devastating flaw was discovered. The telescope's primary mirror, a marvel of engineering, had been ground to the wrong shape. The images sent back from Hubble were blurry, far from the crystal-clear resolution astronomers had hoped for. But what could have been a catastrophic failure became a story of ingenuity and perseverance. In 1993, a team of astronauts embarked on a daring mission to fix Hubble in space. They installed a corrective optics package, essentially giving the telescope a pair of glasses to correct its vision. The result was breathtaking. Hubble, once a symbol of scientific failure, was transformed into one of the most powerful tools in the history of astronomy. It's a reminder that even in the face of setbacks, we can overcome challenges and achieve extraordinary things. Science thrives on open inquiry, on challenging dogma, on letting evidence guide our understanding of the natural world. But what happens when science becomes entangled with ideology, when political expediency trumps scientific truth? Enter Trofim Lysenko, a Soviet agronomist who rose to prominence in the 1930s. Lysenko rejected Mendelian genetics, the foundation of modern biology, in favor of his own pseudoscientific theories, which aligned conveniently with Soviet ideology. The consequences were disastrous. Lysenko's agricultural practices, based on flawed science, led to widespread crop failures and exacerbated the Soviet Union's food crisis. Millions suffered from famine and malnutrition, all because ideology had trumped scientific evidence. The Lysenko affair stands as a chilling reminder of the dangers of political interference in science. It highlights the importance of academic freedom, of open debate, and of allowing scientific evidence, not ideology, to guide our understanding of the world. Imagine believing that the shape of your skull could reveal your personality and intelligence. That was the premise of phrenology, a pseudoscience that captivated the Western world in the 19th century. By examining the bumps on a person's skull, they believed they could assess character and predict the future. Of course, phrenology was utter nonsense with no scientific basis. It reminds us to be wary of pseudoscientific claims and to demand evidence. In the early 20th century, the scientific world was buzzing with the discovery of X-rays and radioactivity. Enter Prosper René Blondlot, a respected French physicist, who claimed to have discovered N-rays. Blondlot reported that N-rays could penetrate aluminum but not lead. But there was a problem. N-rays didn't exist. American physicist Robert W. Wood exposed Blondlot's claims. The story of N-rays is a cautionary tale about self-deception in scientific research. In 1966, a Soviet scientist named Nikolai Fedyakin reported a strange observation. Water confined in narrow quartz capillaries seemed to behave differently, forming a denser, more viscous liquid. This anomalous water, later dubbed polywater, sparked a scientific frenzy. But as with many scientific mysteries, the answer turned out to be far less exciting. Further investigation revealed that polywater wasn't a new form of water at all, but rather regular water contaminated with impurities. The unusual properties were simply the result of dissolved silica from the quartz capillaries and other contaminants. The polywater debacle highlights the importance of careful experimentation and the need to rule out alternative explanations. It's a reminder that even the most seasoned scientists can be fooled by contamination and that extraordinary claims require extraordinary evidence. Stay curious. For centuries, humans have pondered the nature of the universe. Is it eternal and unchanging, or did it have a beginning? In the 20th century, the steady-state theory emerged as a popular explanation for the cosmos. To account for the observed expansion of the universe, they proposed that new matter was continuously created to fill the gaps. However, the steady-state theory faced a major challenge in 1964 with the discovery of the cosmic microwave background radiation, or CMB. This faint afterglow, permeating all of space, was the remnant heat from the Big Bang, the event that marked the birth of our universe. The CMB provided strong evidence for an expanding universe that originated from a hot, dense state, contradicting the steady-state theory. While some scientists clung to the steady-state model, the discovery of the CMB tipped the scales in favor of the Big Bang theory. The steady-state theory's demise reminds us that science is not about clinging to comfortable ideas, but about following the evidence wherever it leads. So there you have it, 10 tales of scientific stumbles, blunders, and outright bluffs. From fake fossils to phantom rays, these mistakes remind us that science is a human endeavor, full of wrong turns, dead ends, and the occasional spectacular crash and burn. But here's the thing about mistakes. They're also opportunities for learning, for refining our methods, for pushing the boundaries of knowledge even further. Every blunder, every misstep, brings us closer to a deeper understanding of the universe and our place in it. And remember, in the world of science, today's mistake could be tomorrow's breakthrough. Stay curious.